Imagine the world as it looked a few hundred years ago. If you wanted to build something that would last, your options were frustratingly limited. You could stack heavy stones on top of one another and hope gravity stayed on your side. Or you could use timber and pray that a single stray spark did not turn your hard work into ash. For centuries, our ancestors lived in a sort of architectural stalemate, where the height and strength of our structures were capped by the natural properties of rocks and trees. We had the ambition to build massive cities and sprawling bridges, but we lacked the literal glue to hold those dreams together.
Before the middle of the 19th century, the biggest problem facing any ambitious builder was the sheer unpredictability of materials. Stone is magnificent, but it is incredibly difficult to shape and even harder to transport. If you wanted a grand cathedral or a sturdy bridge, you needed an army of skilled masons to chip away at granite or limestone for decades. Bricks were a bit faster, but they relied on mortar that was often weak and prone to crumbling when the weather turned sour. If you tried to build something in a harbor or across a river, you were essentially fighting a losing battle against the water, which would dissolve most cements before they even had a chance to set.
This was the hard constraint of the human world for a long time. We were stuck in a cycle of building and rebuilding. Large cities were constant construction sites of wood and clay, and they were dangerously fragile. A single earthquake or a major fire could level a metropolis in a weekend, because our building materials simply could not withstand the pressure. We needed something that was as strong as stone, but as flexible as liquid. We needed a material that could be poured into a mold, hardened into a rock, and survived the crushing weight of the new industrial age. The turning point came not from a grand laboratory, but from the persistent tinkering of people who were tired of watching their work fall apart. In the early 1800s, a few inquisitive minds began to wonder why certain types of volcanic ash or specific limestone deposits seemed to create a stronger bond than others. They realized that the secret was not just in the ingredients, but in the heat. By taking a specific mixture of clay and limestone and firing it at temperatures much higher than anyone had previously attempted, they triggered a chemical transformation. The result was a clinker that, when ground into a fine powder, became what we now call Portland cement. It was named after a famous building stone found in England, mostly as a clever marketing trick to convince people it was just as good as the real thing. But in reality, it was better. This new powder did not just dry out when mixed with water. It underwent a chemical reaction that allowed it to harden even while submerged. Suddenly, we had the power to build underwater foundations, massive sewers, and harbor walls that could face down the Atlantic Ocean. But as revolutionary as this cement was, it still had a fatal flaw. It was great at being squeezed, but it was terrible at being pulled. If you used it to build a long beam, the weight of the beam itself would cause it to snap right down the middle. The real breakthrough that changed the timeline was the realization that we could combine this artificial stone with the strength of metal. This is the story of the race between gardeners, builders, and engineers to create reinforced concrete. Legend has it that one of the first people to figure this out was actually trying to solve a very small problem. He was a gardener who was tired of his large concrete planting pots cracking when the roots of the trees grew too large. To solve this, he decided to embed a mesh of iron wires inside the wet concrete. He found that the iron acted like a skeleton, giving the pot the flexibility to resist the outward pressure of the roots, while the concrete provided the rigid shell. This simple insight was the spark that ignited a global revolution. Engineers quickly realized that if you placed iron or steel rods in the exact spots where a beam was likely to pull apart, you could create a hybrid material that was virtually indestructible. This was the birth of rebar, the hidden steel bones that live inside almost every bridge, tunnel, and skyscraper you see today. It was a perfect marriage of materials. The concrete protected the steel from rusting and fire, while the steel gave the concrete the ability to stretch and bend without breaking.
As the 1800s progressed into the 1860s and beyond, this technology began to scale at a dizzying pace. It was not enough to just have a good idea. To build a modern world, we needed systems. We needed factories that could produce thousands of tons of uniform cement every day. We needed standards so that an engineer in New York could trust that the bag of cement he bought would behave exactly like the one used in Paris. Testing laboratories became the new cathedrals of the industrial age, where giant machines would crush concrete cylinders to their breaking point to record the data.
The economics of this change were staggering. Because the raw ingredients for concrete were relatively cheap and could be found almost anywhere, construction became democratized. You no longer needed to be a king with access to a royal quarry to build something massive. A local business owner could now afford a fireproof warehouse. A city government could afford to build thousands of miles of hidden pipes to bring clean water in and take waste away. This was the invisible foundation that allowed the population of cities to explode. Without reinforced concrete, the skyscrapers of the late 19th century would have been impossible. The walls at the bottom would have had to be so thick to support the weight that there would have been no room for doors or windows. The ripple effects moved through every part of society. The profession of architecture was turned upside down. Instead of being limited by the shapes of stones, architects could now dream of sweeping curves, cantilevered balconies, and soaring towers that seemed to defy gravity. Fire, the great predator of the ancient city, finally met its match. When the great fires of the early 20th century tore through major urban centers, the buildings made of reinforced concrete were often the only ones left standing among the ruins of brick and wood. This technology still matters today because we are still living in the world it created. We have become so dependent on this gray sludge that it is now the most widely used man-made material on the planet. If you look at a satellite photo of the Earth at night, the glowing clusters of light are almost all anchored by the massive concrete footprints we have poured into the Earth. However, we are also facing the legacy of that success. The sheer scale of our concrete production has a massive environmental footprint, and scientists today are racing to find a new version of this ancient recipe that can keep our cities standing without warming the planet. We are essentially back in the kitchens and gardens of the 1800s, looking for the next chemical miracle. We often think of history as a series of battles or political speeches, but the true story of our progress is often written in the materials we use to shelter ourselves. The transition from fragile wood and heavy stone to the versatile strength of reinforced concrete was the silent engine of the modern era. It changed how we lived, how we moved, and how we imagined the future. It gave us the ability to build a world that stays where we put it, providing the stability we needed to focus on the next great leaps in human knowledge. With the foundations of our modern cities finally set in stone and steel, the timeline moves us forward to the next great challenge of the 19th century. In 1867, the focus shifted from the strength of our buildings to the survival of the people inside them, as antisepsis and germ theory began to change the stakes of medicine. We will explore how a series of failures eventually taught the world its most important lesson in saving lives. Join us in the next episode as we continue this journey through the technical breakthroughs that built our world.